Great. Please join me in welcoming our next panel to the stage, who will be talking about navigating landscape-scale nature-based salt marsh restoration in Massachusetts from design to implementation. We have Russ Hopping, Nancy Powell, and Mary Rimmer.
Testing? Hey, beautiful. All right, sorry for that momentary lapse. Do I use those? If you want to. Okay. Good afternoon, everyone. I'm Russ Hopping with the Trustees of Reservations, and I'm joined today by Mary and Nancy. So the three of us are doing presentations succinctly here that talks about this one project, and this is this landscape scale effort to do salt marsh restoration at the Great Marsh. That's you see on screen here now. This is the largest salt marsh ecosystem in New England. It's 16,000 acres of salt marsh, up to 25,000 acres of an ecosystem when you include the barrier beaches, islands, and intertidal areas with that. So pretty significant landscape, and we have been working at the partnership level. Many partners involved. You're going to hear a little bit more about that. But for several years now to really look at the resiliency and the restoration of this entire salt marsh ecosystem using nature-based techniques. We're going to talk about three of those today. This may sound familiar to some of you. Hopefully, if it does, you'll still get something out of it. If it's not, hopefully we're not going to skim through this so fast that you won't understand what it is that we're doing. And we may talk fast through this, but we're trying to get some time at the end to really take advantage of the panel discussion. Well, hey, that works. So I just wanted to set the stage, and I'm going to talk about design a little bit, and then what constitutes success for our partnership here. So I'm not going to talk about these, but I hope you'll all agree that why salt marshes are important and why we want to protect them or restore them. This is just the five of the top ones that the partnerships really look at to think about, well, why are we doing this? I'm sure you could probably add to that. Why do we need to do restoration, right? Is there a problem? Well, yeah, this is what we're facing. Probably not new to people here, but even looking at the low, intermediate, high projections that are predicted for sea level rise, we can see out by, those are the blue lines that you see there. The green is what's been happening. We are projected to see an uptake in sea level rise. At even the lower projections, you're looking at 4 to 5 feet by the end of the century. Cut back 50 years or so, looking out 25 years from now, we're still looking at a foot or two in this scenario. So the question becomes, can the salt marsh keep pace with that sea level rise? And the answer is maybe, if it hadn't been altered in the past. Hopefully some of you have seen this image by now, but we have a pretty vast historical legacy from agriculture that has been added to by mosquito control, lots of other alterations in the salt marsh. But the bottom line for all of this intervention is the natural hydrology of our salt marshes has been completely altered. What does that mean? So what that means is, and this is an example of aerial shot of some of that salt marsh. Nature does not create straight lines like this, nor does it create lines this close to each other. So what's happened here is this alteration has impacted the hydrology. So if you think about every ditch you see there, when it's not full of water, oxygen is able to enter into the peat. What is peat? Peat is up to 80% undecomposed organic matter. It's the grasses that build that marsh peat that are on top, that is the source of that peat, and you get subsidence. You get decomposition, right? So subsidence is going in the wrong direction if we're looking at sea level rise. Looking at this picture too, you'll see there's a lot of ditches. So there may have only been 1 or 2 natural creeks in that area, but now there's a lot more ditches. Why does that matter? Well, when the tide is incoming and it's full of all that sediment on every single tide that comes in, it now has to go through many more ditches than it did natural creeks. The velocity slows down and that sediment load drops out and it clogs all those ditches. When that happens, groundwater rises, it gets to the surface, it drowns the plants that are actually the building block of the marsh to allow it to keep pace with sea level rise. So you can probably see we have subsidence happening under these two scenarios. That's the wrong thing. That's not what the marsh needs if we're looking at 2 feet or more of sea level rise in the next 50 to 75 years. So we call that a problem. So in terms of a goal, defining this project from the very beginning, the partners agreed on we want to restore marsh-sustaining hydrology, natural hydrology. That's the big goal, and we have these 4 sub-goals that really set the stage for, you can't see it in my slide, but I had another note there about by defining these goals and objectives very clearly, that helps us describe what it is we need to monitor to understand if we are achieving success. So we want to stop this subsidence, turn back on the marsh building process, at least keep the high marsh that we have for those environmental services that you saw, but in particularly for marsh species such as the salt marsh sparrow. Massachusetts supports 10% of the global population, the great marsh 5%. And then ultimately allow the marsh to do what it does well if it hadn't been altered, if its hydrology hadn't been altered, to keep pace with sea level rise. So this is what a plan looks like. This is a slightly older plan. I don't know, Nancy, if you're going to be showing a newer one, but it really doesn't matter. I mean, the bottom line is, we have been, each of our projects, we share back and forth. We've been altering our plans to accommodate what it is we've been learning. So we've been doing adaptive management in our planning and our implementation as well. But pretty much you have to develop a plan. This is the design a concept that we have been using and implementing. And just very quickly, the red lines are showing the old agricultural embankments. The blue and the green are the ditches that were created. And then this slide is really showing the 3 to 4 nature-based interventions, solutions, if you will, techniques that we're implementing on a whole across this 16,000 acres, starting right now with 4,000 acres. That's the immediate, what's in play. Short term, we have a goal is for 8,000 acres. Long term, the full 16,000 acres. But I do want to stress the techniques here are transferable to just about every salt marsh in Massachusetts, and there's 45,000 acres in Mass. So the green lines here are ditch remediation. The orange lines are runneling. The orange dots are microtopography, or we call them nesting islands. And then those blue dots are where we're removing by hand those obstructions in our primary or single channels that will essentially serve as those surrogate creeks that would have been there. So you got your design. And then what we've been working on is defining what does success look like. So all of our projects have these success criteria tables or something similar to it. This is just a snapshot to give you a flavor of kind of how this process works for us. So you'll see that green line is just, it's really explaining, okay, the goal is habitat for salt marsh sparrows, but this is creating these nesting islands. And then you'll see it's, all right, we're going to do this using the spoil from creating those runnels. And so there's 2 specific objectives here. There's more, and for each of those objectives that I showed earlier, we have multiple other ones of these. But when we create the islands, we literally say, how big are those islands? And then over time, how frequently do we monitor them? And then what are we looking for some basic metrics on year 1, year 2, year 3? We thought this was going to be a 3-year project. We now know it's at least a 5. We're working at the speed of nature. We're not trying to create radical change overnight. We're just trying to nudge Mother Nature back into what she does so well. So we've adjusted our expectations for about 5 years now. But you'll see, by year 3, we want these islands to be stable, and if they're not by 25% less, we could intervene. If it's less than 25% change, we're still okay. I can tell you that the work so far, we don't have an issue. We're meeting that. The only time we didn't is when we didn't stake our islands down and a tide came in and washed them away. So we immediately addressed that by putting stakes in. And then the second one here is perhaps more interesting. It's as we create these islands, we want them to fully revegetate with high marsh vegetation, and we know that's going to take time. You can't just change vegetation overnight, so you need to be realistic and give it a few years. In this case, we're pretty much right on track. We know by year 3, most of our islands are achieving this 75% or more of being vegetated with salt marsh grasses. A few have not, and we know why that's the case, and this is another reason why we're saying we need 5 years now. So nature's corrected our timeline, so to speak. In terms of what we monitor, this is just a snapshot. We do the birds, we do mosquitoes. Mosquitoes are always a hot topic. That's why we wanted to make sure that we included them. Public does not like mosquitoes, and our philosophy was the restoration work is making less mosquito habitat, so we wanted to make sure we could actually say that. So this is the variety of things. I just want to explain what UVVR is if you don't know what that is. That's unvegetated versus vegetated ratio. The reason I want to highlight this is as we scale up, and we're now working, the trustees, U.S. Fish and Wildlife Service, we're working at 1,000 acres at a time now. So as you can imagine, I don't want to be that person walking out there with a tape measure and collecting plot data on 1,000 acres. So we have to be adapting to, the, in this case, remote technology that allows us to assess how is the marsh responding at that scale. It makes these projects affordable. So, and I just want to close here and just say, don't underestimate photos. They can be very important, in this case, from photo stations. And this was the very first nesting island that we created, and you'll see there on the left, that's the picture after 6 months of creating it, that first growing season. You can see all that beautiful red. That's an annual plant. There's some bare patches, but 2 years later, same island, same spot. You see it's now covered in 100% in salt marsh grasses. The top of that is Spartina patens. That is the classic salt marsh grass of high marsh. And if I didn't point it out and we were out there, you probably wouldn't even recognize it. So there we have a very obvious, with a checkbox, we've met our criteria, our monitoring criteria, et cetera, and we can communicate that. So with that, I just want to thank all the partners, and I do want to stress this is a very large partnership covering thousands of acres. And I'll turn it over to Mary to talk about a very important piece which we've learned a lot about, and that is how to get a project like this permitted.
Great, thanks. Which do you use? Enter?
I'm just using the down.
Okay. Thanks, everyone. So again, I'm Mary Rimmer from Rimmer Environmental, and I've been working with these project partners to try to take these great landscape level solutions through the challenges of permitting to allow them to be implemented. And we're fortunate in Massachusetts that we have strong wetland protection regulations. And the downside is that it makes it challenging to do good things as well, because the regulations were largely written 40 years ago and didn't anticipate that we would need to do this kind of work. So the agencies have been beginning to respond and trying to streamline permit processes for beneficial projects like this, but it is a slow process. And to give you some idea of the timeline, it's taking anywhere between a year to a year and a half to, once we have a completed project, to get through the permitting process. So the first step in that process is building a quality project team. And you really need to consider what it is that you need. Now, Russ talked about this restoration being a three-pronged effort. So we have measures to address marsh subsidence due to waterlogging that's causing the marsh to subside, and that's addressed through construction of these swales or runnels to improve the drainage in certain areas. We have subsidence occurring due to over-oxidation or over-drainage of the marsh from the excessive ditches. And then we have an opportunity to beneficially reuse excavated material that's generated from the runnels to create some high marsh habitat to support rare species, including salt marsh sparrow. So there are other prongs of these restoration efforts, including invasive species removal, but really these three elements are really intended to restore natural marsh hydrology and improve long-term resilience of the marsh, so that we have a prayer of trying to keep up with sea level rise. So some of this work requires engineering support. A lot of this work, because it's such large scale, we've used some innovative methods in more GIS-based mapping and site plans, but we did need to do cross sections and Chapter 91 license plans. So there is some engineering needed. We're looking into the possibility of using drones more for collecting data to support these projects, creative uses of GIS mapping, and then, considering before starting these projects whether there's tidal monitoring that's needed, if there are any culverts that need to be removed as part of this, then there might need to be, extensive tidal monitoring to monitor what the hydrology is doing. Are you in rare species habitat? Will you need any rare species surveys, monitoring of fish habitat? All these things have to be considered up front in the process of preparing for permitting. And then because the permit process can be quite lengthy and a little bit tedious at times, you may need a permitting specialist, because it also requires a fair amount of effort over an extended period of time. Often the nonprofits that are supporting this work and the agencies don't have the staff available to do that. DEP does encourage that this work be associated with universities or other organizations that are familiar with these restoration techniques, so that it's not, they're not being done by smaller groups or individual homeowners or anything like that. This is work that's being tackled as a collaborative effort, and each iteration of this restoration has been forwarded to the next practitioners so that they can take advantage of some of the information that was generated, and also pave the way for the permitting for others in the future. So there's been really good collaboration between the various groups that are doing this work. DEP often requires a wetland scientist with a minimum of 5 years of restoration experience to be in the field during the implementation of these, so you have to consider that staff as well. And then there's SMART team collaboration, which is a salt marsh adaptation and resiliency team. I think Nancy's going to talk a little bit about that. And then understanding the project. Before starting the permit process, it's really important that everyone that's involved thoroughly understands and is prepared to answer questions about the project, or you will get caught up in the process. So you must really be, and we've had to develop language as we went along, because these are innovative techniques, to be able to have a common understanding among ourselves, but also among the regulators, so we've been educating them as we've gone as well. So the permitting process has taken a little longer just because these are innovative techniques, and the agencies haven't seen these very much yet. So you must be able to describe in detail the restoration techniques and how they'll be accomplished. What are the expected impacts, both temporary and permanent? What kind of proposed mitigation measures are to be used? For example, for these projects, the equipment operates on low ground pressure construction mats and leapfrogs across the marsh, sometimes very far across the marsh. So there needs to be a project sequencing and coordination plan just to get equipment where it needs to go. What are the project alternatives? What kinds of things can you consider to do? Different runnel sizes, different ways of treating the ditches. All of those need to be fleshed out so that as part of the review process, what kind of monitoring program are you going to have? Who's going to do the monitoring? How long will the monitoring last? How is that tied to the success criteria for year 1, year 2, year 3? These are multi-year projects, so most of the permitting is for 3 or 5 years. Often they'll need to get extensions because some of the results that we're looking for are a little further down the road. There are some immediate results, and for example, the runnels tend to have a more speedy results. For the ditch remediation work, where you're actually mowing the salt marsh hay and placing the hay into the ditch to try to allow that ditch to heal itself, depending on the size of the ditch, may take several years and many treatments. So this is a partial list of potential permits that may be required and were in fact required for, most of which were required for these projects. Alteration of anything greater than 1 acre of salt marsh automatically bumps you into an environmental impact report. We've been able to work with MIPA to try to get the environmental impact report to do an expanded environmental notification form rather than an EIR for this latest phase of our project. And there have been special review procedures in consideration of this innovative procedure. So MIPA's been working with us to try to expedite the time frame, but also ensure that we have we've satisfied all the agency concerns that are part of that review process. Under the Mass Wetlands Protection Act, there's an ecological restoration provision that allows you to avoid the MIPA process, but unfortunately, because this work is relatively new, it doesn't qualify for that yet. It will eventually, as enough projects come through that are similar, but right now we still have to go through the MIPA process. And then there's a 401 water quality certificate. In some projects, there might be some dredging required. We didn't have any dredging as part of the projects that we're talking about today. Mass Chapter 91 licensing is required because where there's work below mean high water for the placement of the hay in the ditches. We had Mass Endangered Species Act determination because of the salt marsh sparrow and also least in common tern. Mass Division of Marine Fisheries weighs in. Mass Historical didn't. The next two, Mass Historical and Mass Underwater Archaeological Research Board, had no concerns. Mass Coastal Zone Management, very involved throughout the whole process. Good feedback from them. Same with the Army Corps of Engineers, and then no MIPA required for these projects. So there are things that can be done to streamline the permit process. Requesting pre-filing meetings with regulators is really important to try to get that, get feedback right away on what kinds of questions that they might have. Strategizing your permit sequence so that some of those permits can overlap. Many of them have to be applied for in sequence, but some do not, so making a plan for that. Developing a project permit template that you can reuse information for one permit and the next and the next. They all have their separate forms and application process, but a lot of the information can be generated that will be useful to all the different permitting agencies. Ultimately, we'll take advantage of the ecological restoration provisions of the Mass Wetland Protection Act, and then use online permit portals, obviously, whenever possible. One of the things that I didn't mention was through this permitting process, Mass DEP came out with new guidance to develop some consistency on the materials that need to be submitted for this type of project. That happened right during the MIPA review process for our phase 3 project. And so now DEP does have policy guidance, so there's a little bit clearer information on what type of information is needed to complete these kind of projects. I won't go through this whole permitting timeline, but it just gives you some idea that it can extend many, many months. And the better job you do in preparing and getting information collected and having a clear project plan, the easier it is to get through the permitting process. And like I said, it's getting easier as each iteration of these projects come along. And then finally, once you've got the permit, you're not quite ready to start construction yet. You still have to figure out how to track your projects for permit compliance. And that, as I mentioned, requires having somebody on site to make sure that you're doing the work according to all the permit requirements. And then, as Russ mentioned, you have to track your design success criteria for anywhere from 3 to 5 years out, making sure that you're hitting that and providing annual monitoring reports, because if the monitoring reports come back and say, this isn't working exactly as we planned, you may not be able to proceed with additional work. And then finally, getting a certificate of compliance. So I'm going to pass it on next to Nancy, and she's going to talk about, once we get all that in place, what the implementation looks like.
Thanks, Mary. So my name's Nancy Powell. I work for Fish and Wildlife Service at the Parker River National Wildlife Refuge. And thanks for Russ and Mary for teeing up how you go from an idea to plans on a map through permitting, which takes a couple years, like probably 3 years now at least since we first thought of the plans. So I'm going to be talking about implementation, which when you're talking about projects that's over 1,000 acres, it's a logistical challenge, as you can imagine. So we've been trying to figure some of that out. We're on year 2 of our project right now. So as Russ says, there is about, I think, 3,000 acres that's either in progress or has been completed. So the one I'm going to be talking about, this is the one I'm working on right now. It's the 1450 project, and it's 7 units that totals 1,450 acres. When we got this permitted, which was, I think, like end of March 2024, so last year, we actually went to implementation the next week. And luckily, I'll talk a little bit about that. Fish and Wildlife Service has a lot of in-house capabilities, and I was able to pull some resources, and that's why we were able to so quickly get out there as soon as we have the permit in hand. But it's a lot of different features, so over 700, I can't even read it actually, over 700 ditches and almost 400 runnels. I have a 3-year grant to pay for this, but we had actually already used up 1 year for permitting. And as Russ says, these projects tend to take multiple years just because of the techniques that we're using. So when we were planning this project, we knew that it needed to be a multifaceted approach. So I'll take a minute to talk about the design a little bit. This looks a little bit messy, but basically what you're seeing here is the blue is existing channels, the green are ditches that we're remediating, and the orange are runnels we're creating. So when we're done, basically all the green goes away, and what you're left with is a channel network that's in equilibrium with the marsh surface that is flooded. And they tend to be also tiered so that channels will branch and get smaller as they go up into the marsh surface, and it flows back during an ebbing tide, and that volume of water and the channel dimensions will be in equilibrium or will evolve over time with sea level rise and storm surge. So that's our goal. So because of all the work that needed to happen, I wanted to have a couple of in-house teams because we wanted to figure out how to do this on a very detailed scale for a project like this before we started contracting out. We also wanted to be able to contract some of this work out because we knew that we needed to increase capacity, because as Ross says, just in the Great Marsh alone, we want to do 8,000 acres. That's a lot of acres. And right now, there's only a handful of people that know how to do this. And we also build in a lot of opportunities to train people, anybody that's interested in learning how to do these techniques, to have them come on and work with our team so that they can learn how to do this as well, take as much information as they can back. So I'll start with our Fish and Wildlife Service maintenance team. So I work in the National Wildlife Refuge, and refuges are really lucky in that we have amazing maintenance staff. We only have one that manages 4 refuges in 3 states, but he is amazing and very skilled. And they have such amazing knowledge of how to use heavy equipment in sensitive habitat. A lot of them have ecological backgrounds. Mine was actually the wildlife biologist previously. Decided it was too much desk work and became the maintenance guy. But he knows, he knows hydrology, he knows plants, he knows everything. So when he's out there operating a machine, I don't have to worry about anything. We have a structure that's been in place for a number of years where maintenance staff from different stations will actually get together to get projects done. for kind of a cost savings to the agency, but also as a skill building. They're kind of learning from each other how to do different techniques. And it provides a little bit of kind of overtime, which is helpful. So we kind of use that approach for this project as well. We had a lot of other maintenance staff from Vermont, from Maine, from other areas come down and help us on this project. And some of the newer folks actually just needed seat time in the machine, so they were able to get seat time to get their certification to operate a machine while they were doing this project, and we got a lot of that done. And the most important thing for me was, we have these plans that, it took us like 18 months to develop, but before we put it out to bid, we needed to flush out a lot of details to put that scope of work out to bid. And I didn't know how to write it. I knew how to write it from an ecological standpoint, but not from a maintenance operation standpoint. And our maintenance workers helped us figure out, exactly what is the pounds per square inch, what kind of machines are usable. So they have all that skill and knowledge. The funneling also provides a lot of opportunities for a lot of hand help. So we've had a lot of people join us, including my boss with the Fish and Wildlife Service in the back. He was out there a couple of days helping us haul sediment to build those islands. It's muddy and tiring work. So as I said, we wanted to make sure that we put something out to contract. We picked the smallest unit. That was about 100, so it's 138 acres, or 10%, less than 10% of the whole project, and put it out to bid. It came back at like 3/4 of the cost of our whole project. So we're like, okay, that's not gonna work. So we've revamped a little, talked to some of the companies, and we put it out to bid again with just funneling. One lesson we learned, it was kind of a busy time, and we just picked the time. Ducks Unlimited is doing this work, and they picked the time, and I didn't check the tide charts. So I'm like, sure, I'm free that day. And we go out to the project. This is us crossing the creek that you have to cross to get to the site. Every single one of us went up to our waist on a cold day. So that probably increased the cost a little bit when the bids came back. But when we bid it out again, we were able to successfully get a much lower cost just for the funneling, and the contractors were able to figure out how to cross that ditch. And they actually just finished yesterday. We did the site walkthrough. So it took them 3.5 weeks, what they expected to take 7 weeks. So hopefully next time around, the bids will be even lower because it's actually less work than they had anticipated. So we also take advantage, there's a lot of really incredible partners in the area, and the mosquito control districts was a partner early on in helping us figure out what was happening in the marsh, as well as piloting some of these techniques. And I kind of begged them to come back and get involved in this project again. So they've come on, they have specialized equipment that makes it go a lot faster. And they've been incredible, and hopefully they'll continue to help with that project. So the crew that I'm really excited about is our ditch remediation crew. So this is in partnership with Mass Audubon. We hire early conservation professionals, so typically students straight out of college or still in college. And they work as a team, and they mow, they hay, they rake, they stake. That's kind of the process for ditch remediation. It's a lot of work, but it's also an opportunity for a lot of skill building. Because they're always working in a team, we're able to hire folks that have great attitudes, but maybe didn't get into conservation because every early conservation job is like a volunteer, and not everyone can do that, right? So we've actually hired some kind of non-traditional folks onto our teams, and they've been great. And one of the ones I've hired is actually 3 years ago, is now leading the team right now. And we look for different types of skills. We're able to do that. And this is also where we take a lot of volunteers, and they come and help join us. So Ducks Unlimited on the left, getting in the ditches with us to help us do some of these. And then one thing I will say is when you have over 1,000 restoration features that you need to do, it's really, really important to track it. So we do that through a AGLL, basically field maps component. Everything's integrated from construction to management to monitoring data, our plans, and the contractors have successfully used this, so this has been really great for us. I won't talk about this again, but again, the partnerships, everyone has different strengths, and whenever we run into a barrier, it seems like one of our partners had the skills necessary to kind of move us forward. So for that, I think we can take some questions. These are some of our team that this is last November. They've been out in the marsh for 3 months, and they're still very enthusiastic and excited about their work, as you can see. So I don't think we really have anything planned, so if you guys just have questions, we're happy to take questions and answer them.
Thank you all. I have a question, a million questions, I think, but I'll start with the design and the alternatives analysis and kind of trying to reach that equilibrium hydrology that you talked about. How did that come about?
Can I answer that?
So the team member that's not here today is Jeff Wilson from Northeast Wetland Restoration. And this is, the design is largely, his conception of using the historic agricultural infrastructure that's in the marsh as a basis for conceiving equalized hydrology. So all of that infrastructure changed the way the marsh ebbs and flows, and rather than trying to eliminate all the infrastructure, trying to work within that infrastructure as much as possible to do that. And so it was trial and error. There's lots of different ways of creating runnels. Some of them are compaction runnels that are done by hand. Some of them, the early ones were hand dug with a grub hoe. And then eventually it's been, the techniques have been refined enough so that he now has specialized equipment that has a excavator bucket that is customized to the exact runnel depth and width that's necessary. And the idea is to just make it as small as possible and allow it to develop on its own based on the amount of water that it conveys. But the alternatives analysis was difficult to do when you're talking about a new concept. But there are other salt marsh restoration techniques like thin layer deposition, which is the main one, and that's being discussed more and more as a potential alternative. But that wasn't what we wanted to do for this project, and the state isn't really ready to approve those projects yet. Getting close to doing that, but they're not there. So can you think of any other alternatives that we considered?
I mean, I think we did talk about the alternatives of not doing it, and I think that was really, it was really challenging. We went through a lot of iterations trying to explain how the marsh is trying to heal on its own and not succeeding in instances. So we used a lot of Google Earth images to show cases where entire marshes have basically become pools because they were not able to kind of respond, and like the fact that a lot of the techniques that we are using was happening in nature, and we're just trying to accelerate it, yeah. Two things I'll say about design is that, one is that Pat Huckery from Mass Wildlife, who is one of our partners, is trying to expand kind of teaching people how to do design so that more people can do it. She's launched the first small team academy for Massachusetts And I think there'll be others down the line. So this is Jeff and others teaching other folks how, we do this. And then the other thing is we have been having some conversations with actually folks from Delaware about how to develop empirical models. Like, how do you look at a site that is healthy? And I think the toughest part is finding a healthy reference marsh and look at relationships, look at the China with marsh area, look at density of creeks, look at sinuosity. So we're looking at sites that look good and trying to find those formulas so that we can apply those to our design. And I think that for DEP, that's really what they're looking for, that a little bit, they're supporting us, but they're a little bit uncomfortable with the try it method that we're using, watch nature and do it this way method that we're currently using.
Yeah, when we do have a new technique, we'll do it in a pilot area, a smaller area, not apply it across the whole marsh.
Assuming this works. Hey, it does work. I'll just add to that. I think for me, there was an aha moment when I realized that the design is really based on reverse engineering what has happened to the marsh for hundreds of years. So it was really about thinking, okay, what did those farmers and mosquito control, et cetera, what did they do to the marsh and what were they trying to alter? So if we understood that, which I think we're understanding much better, as we've gone through this process, it's like, okay, now we just have to undo that. What does that mean? And in many cases, it's using the same techniques that the farmers used. It's just using them in a new way to do restoration.
Have time for one more quick question.
Quick question. In terms of replicating nature's process, I think you kind of addressed one of my curiosities in terms of monitoring and sort of checking in to see if things are going in the direction that we want it to go. I guess my question is, in terms of setting up a constituency for this particular project, so we're not necessarily just only talking to nature or looking to nature for feedback. I'm wondering if there's an opportunity to kind of set up an academy of sorts which brings youth. And you talked a little bit about, finding ways to engage youth in maintenance and other sort of ways of engaging with this landscape, which I think is an enormous opportunity for folks who are interested in science. And I'm wondering if there were other ways that have been experimented with to create a community that cares for this landscape and can be a part of the stewardship theme moving forward. Just curious.
Yeah, so I have the staff that I hire, so through this grant, I have about 10 people that work for me, kind of some of them year-round, some of them seasonally, and all of them have been amazing communicators. So in addition to having people join us to do the work, they often will put on tours, site visits in the field, so we're actually showing, there's nothing like showing people what it looks like after we do the restoration and taking them to a site that hasn't been restored and talking about it. It's hard to see on a slide. And then we also do work with a lot of the local high school students that are very into community engagement, and those topics tend to be more broader, but it's really engaging the community of what do they want, how do they want to think about their relationship to the nature, and how does the salt marsh kind of fit into the community identity. And that has been super successful. I would say some of those student-led workshops that I've been at, I've never seen so many people in tears thinking about their relationship to nature. And like, I just remember one, we had over 100 people. We had like 12 kids lead it. So many people came up to us afterwards and were like, what can I do? I don't know anything. I have a piece of marsh. What can I do? And that's really amazing.
Thanks so much. We are out of time, and I hear people probably wanting to come in and snack. Please join me in thanking both of our wonderful panels this afternoon.